So the trick to all of these problems is that all of these have been jury-rigged so that they give you special angles. So let's just remind ourselves that of the various special angles. For pi over 6, sine of pi over 6 is 1/2. Cosine of pi over 6 is √3/2, and tan of pi over 6 is 1/2 over √3/2 is 1/√3. And then for pi over 3, things are switched around. How do you switch something with itself? Well, you just flip it. This time it's got √3 on the top, so tan of pi over 3 is √3. Other special angles, let's see. Some things to note: sine of pi over 2 is 1, cosine of 0 is 1, and tangent of pi over 4 is 1. And then, and then we have to go into other quadrants sometimes, but those are the basic ideas that we're going to be looking at. So if I start dealing with this, I'm going to start by just taking the square root. And this is wrong. What's wrong with it? How many times do you hear me say that? What's wrong with it? Why did I leave a space before the square root sign? Oh, that's what's wrong with it. I know, you'll see the ghost of the plus or minus sign. Yeah, so I'm going to be doing two things. Tan theta equals √3, and tan theta equals negative √3. And we're trying to find all of the angles between 0 and 2 pi. So if I look at this, again, one of them is pi over 3. But then the other one is the version of pi over 3 where sine and cosine are both negative. So that would be the third quadrant version of pi over 3, which is 4 pi over 3. Again, 1, 2, skip 3, 4, 5 is the one in the fourth quadrant. So if we're looking at tan theta being negative √3, we're looking at the negative slope version of the same thing. So we want the second and fourth quadrant versions, 2 pi over 3 and 5 pi over 3. Okay, so we are going between 0 and 2 pi, so those are the ones that we want. I don't want negative angles. Okay, cosine squared equals 1. Cosine is 1, or cosine is negative 1. Okay, well, with these things in mind, it should be easier. Remember, cosine is the x-coordinate. Cosine is 1 at 0, and cosine is negative 1 at 180 degrees, which is pi. So, but careful, there's an equal sign for the 2 pi, so I can also go to 2 pi. Always check your endpoints. If it's theta is going from 0 to 2 pi, remember that 2 pi has to count also. Okay, cosine 2 theta equals 1/2. We're going to do it this way. We'll figure out 2 theta, and then remember that if theta is between 0 and 2 pi, 2 theta can go around twice. Okay, so when does cosine equal 1/2? Let's just, oops, that's fine. I'm trying to draw circles. They're so much harder to draw on my iPad. Okay, so when does cosine equal 1/2? Remember, cosine is the x coordinate. Looks like we're closer to the y-axis. This is pi over 3. This is what? 2, 4, 5 pi over 3. Okay, so cosine, so 2, but you can also go around more than once. So 6 pi over 3, 7 pi over 3. 8 pi over 3, 9 pi over 3, 10 pi over 3, 11 pi over 3. 12 pi over 3 would be 4 pi. Okay, so 2 theta can be pi over 3, 5 pi over 3, 7 pi over 3, or 11 pi over 3. Notice that 7 pi over 3 is pi over 3 plus 2 pi, and 11 pi over 3 is 5 pi over 3 plus 2 pi. So cut these all in half. And we get the 4 answers that theta can be.